Hello students, welcome to my YouTube channel Easy Mathematics, and it is after a long time when I am again back and giving you a lecture on indeterminate forms. So what is indeterminate forms that you should know? And in this lecture we will come to know about this indeterminate forms and one rule which is called the L'Hopital rule with lots of examples. I hope you can enjoy the lecture. So first of all, what you can able to see here, few limits, and I hope these limits are very much well known to you. Yes, these all are the standard limits, and you know that these all we remember or learn as a formula. Yes, it is limit x tends to 0, sin x by x is equals to 1, that we know. Similarly, log 1 plus x by x when the limit is 0 is 1. Likewise, there are so many standard limits are there. But do you know how these values are there? Is it possible that without remembering all those standard limits, we can calculate the values of those limits? Yes, it is possible. But the thing is, when we come to these type of limiting functions, that time we stuck somewhere because these all are in the indeterminate forms. So first of all, how to find out or how to identify that a function is in indeterminate form? So for that, you just find out a function in the denominator and numerator format. And if we take the limiting value individually to its denominator and numerator functions, then we find out that these limiting values are 0. That means the limiting value of the denominator as well as the numerator both are 0. If it is, then we say the function is in indeterminate forms. So indeterminate forms mean we can say the denominator 0 and numerator 0 means it is in the form of 0 by 0. So in that way, we can say if a function is in the form of 0 by 0, then it is called the indeterminate form. So not only 0 by 0 is the indeterminate form, but there are so many more forms are there, such as here if we shall find out any limiting function where the denominator and numerator are just like infinity by infinity. Otherwise it is infinity minus infinity or 0 into infinity or 0 to the power 0, or it is 1 to the power infinity, or it is infinity to the power 0. All are these indeterminate forms. But before starting these indeterminate forms, with lots of example, we come to know how a function is indeterminate. And we should identify first of all the indeterminate forms and which type of indeterminate forms are those. After identifying those, we are going to solve those problems. So first of all, let us start with one example. So here it is the first example. Here you just observe the given limit is x squared divided by e to the power x minus 1. Here at first we say that fx, let us consider fx is equals to x square and gx, that one is equals to e to the power x minus 1. Now if we consider limit x tends to 0, then definitely this functional value is 0. And similarly, if we consider limit x tends to 0, then e to the power 0 is 1 and 1 minus 1 is 0. So that this one is 0, this one is 0 at the limiting condition x tends to 0. So we can say the given limit is in the form of 0 by 0. Is it? So when we find out it is in this form, we identified that it is the indeterminate form and it is in the form 0 by 0. Let us consider the another one. So here again one function is given and here we can say fx, that one is equals to x e to the power x minus of log of 1 plus x, and gx we can say that it is x square, and very obvious when it is x tends to 0 we shall find out it is 0, so that it is 0, and log of 1 plus 0 means it is 1, log 1 is 0, that we know. So the functional value at the point x is equals to 0, it is 0, and here gx obviously it is 0, so this one is also in the form of 0 by 0. Now one more question is here. So here one more example. So for this one, here it is limit x tends to 1 and this one is given. Here we can say fx, we consider fx is equals to 1 plus log x minus of x and gx is equals to 1 minus 2x plus x square. So just have a look, when we substitute x tends to 1, that means x is equals to 1, that time we find out this one 0 and this one is also 0. So this is also in the form of 0 by 0. Now consider another function, which is this one. Here our fx is equals to x square and gx is equals to e to the power x. When the limiting value we substitute, limiting value is given here, x tends to infinity. So when we substitute, we find out if x is infinity and gx is e to the power x, means e to the power infinity, so it is also infinity. So we can say this is in the form of infinity by infinity. So this one is in the form infinity by infinity, and if the form is infinity by infinity, then easily we can convert it into the form of 0 by 0. Just if we write this one as if limit x tends to infinity and 1 upon e to the power x divided by 1 upon x square. So that means what we have done here, we have written here 1 by gx divided by 1 by fx. If we can write the given limit as in this format, then we can say now the limit is a 0 by 0 form. So if we know the 0 by 0 form only, then also by the same process we can solve this limit. Otherwise 0 by 0 form itself also can be solved exactly in the similar manner as we solved the 0 by 0 form. How to solve? Gradually I am coming. Just let me show you a few examples, and we should identify initially that these are in which format. After that we are going to solve all those. So now here one more example, and here it is given that fx is nothing but it is log of x minus pi by 2 and gx is equals to tan of x. And I hope you can understand that here when x tends to pi by 2, then we find out it is log 0. Log 0 is always infinity, and gx is tan pi by 2, tan pi by 2, so that is also infinity. So this is in the form of infinity by infinity. Similarly, one more example let us consider. Here in this example we shall find out that fx, which one is equals to 1 square plus 2 square plus 3 square, and in this way it is up to x square. That is nothing but the sum of the square of the natural number. So we know its formula, and its formula is n into n plus 1 into 2n plus 1 by 6. I hope all of you can remember this one. And here I have written n, but as it is the in terms of x, so instead of n we should write it as x, is it? And if we simplify this one, then we should find out the value for this one is 2x cube, then plus of 3x square and plus of x divided by 6. And we will have here gx is equals to x cube. So in this functions, if we substitute this limit, then we shall find out this fx is tending to infinity and gx is also tending to infinity when x tends to infinity. So the given limit is in the form of infinity by infinity. So one more example is here. In this example we shall find out, and we consider that fx is equals to 1 by x, and here the gx is equals to cot of x. Now when x tends to 0, then fx definitely it is infinity, and gx means cot 0, that is infinity. So this is in the form of infinity minus infinity, is it not? So this is in the form of infinity by infinity. If a given function or a given limiting value is in this format, that is infinity by infinity format, then also we can convert it into the 0 by 0 form very easily. So how, if we want to know that answer? So for that I can see that here if we just simplify this one, so here the entire thing, if we simplify like this one, 1 by x minus cot x, we can write as cos x by sin x. So now if we simplify this one, then we shall find it out as sin x minus cos x and x cos x divided by x of sin x. So now if we say that fx is, the new fx is sin x minus x cos x and gx is x sin x, then when x tends to 0, then sin 0 0, and it is 0 into something means 0. So here it is the 0 and x sin x, definitely this one is also 0. So this one is in the form of 0 by 0. So after getting in this format, that means we just rewrite the given function in this format, we will find out it is in the 0 by 0 format, and it is in the 0 by 0 format means the same process we should apply to evaluate this one. But for generality, I can say that if any function in the form of infinity minus infinity form, then we can always convert it into the 0 by 0 form, and the transformation is 1 by gx minus of 1 by fx divided by 1 upon gx into fx. So this one is same as this one. You just evaluate and you just calculate, and we shall find out that the same thing I have written here. Now one more question is here, and in this question again this is in the form of infinity by infinity. Just have a look, because here the fx we can say as x divided by x minus 1, and gx is, it is 1 upon log of x. So again we just simplify and transform it into the form of 0 by 0, and we should proceed to solve it out. Now if your function is in the form sin x log x, so here you just have a look, two functions are again given here. So fx we consider is sin x, and gx we should consider as log x, so that here if we substitute x tends to 0, then sin x that means sin 0, that is 0, but log 0 that is infinity. So it is in the form of 0 into infinity. So this is also the indeterminate form. And if you have this type of format, then you can write as the fx divided by 1 by gx. So that just have a look, we will have the same function. And if we write in this format, then it is in the 0 by 0 format. So after getting in the 0 by 0 format, we can solve in the same process. Now one more question is here. In this question again it is the fx is your, it is 1 minus of sin x, and gx is equals to the tan x. And if we substitute the limiting value pi by 2, then we shall find out it is 1 minus sin pi by 2. Sin pi by 2 means it is sin 0 0, and pi by 2 is 1, so it is 0, and tan pi by 2 is nothing but infinity. So that this one is also in the form of 0 into infinity. So that again we just rewrite it into the form of 0 by 0, and we should proceed to solve. Now come to this example. In this example, we have fx is equals to x plus sin x, and gx is equals to tan x. That means this one we consider as fx, and this one we consider as gx. If this type of form is given here, this value is 0 and tan 0 is also 0. So that we have in the form of fx to the power gx, where fx is 0 and gx is 0 for this limiting case. So that is in the form of 0 to the power 0. If we have this type of forms, then to convert it into the 0 by 0 form, we should take log on both sides. And let us consider y is equals to this entire function and take log on both sides. If we do so, then it is log y is equals to tan x, then log of x plus sin x. Now tan x means when x tends to 0, that value is 0, and log 0 means it is infinity. So this one is in the form of now 0 cross infinity. So this is the indeterminate form, and we know if we have the form 0 into infinity, then how to solve it. So at first we solve this function, and after completion of the solving, we take the antilog to find out the value of y, and hence we will get our desired answer. Similarly, one more example if we consider, then it is here, and here we shall find out that fx is equals to e to the power x plus x, and gx is equals to 1 upon x, and this value is, it is infinity when x tends to infinity, and gx is definitely 0. So it is in the form of infinity to the power 0. So if this form is there, then also we will do the same thing. We take the log on both sides and we shall find out log y. If we say this one is the y, then log y is equals to 1 upon x, then e to the power x plus x. So this is in the form of, now it is 0 into infinity again. So if in this form we can have, then from here easily we can convert it into the 0 by 0 form and we can solve it. How to solve? I am coming soon. One more example, that is the limit x tends to 0. It is 2x plus 1 divided by x plus 1 whole to the power of 1 by x. So here it is the fx is equals to nothing but it is 2x plus 1 divided by x plus 1 and gx is equals to 1 upon x. So here we shall find out when x tends to 0, then this value is 1, and for x tends to 0, this value is infinity. So it is in the form of 1 to the power of infinity. So if this format is given, then again we take the log on both sides and we shall find out log of y is equals to 1 upon x. Then it is 2x plus 1, here it is log definitely. So 2x plus 1 divided by x plus 1. And now it is in the form of what? Yes, it is infinity into 0. Yes. So now it is again we can convert into the 0 by 0 form. And one last example for this lecture is this one, and that is x to the power 1 minus x, and the limiting value is x tends to 1. Here we say that fx is equals to x and gx is equals to 1 by 1 minus x. So that when x tends to 1, this is 1 and this one is definitely infinity. Yes, and it is in the form of 1 to the power infinity. So whatever this type of forms we shall find out, we will take the log on both sides, and after taking log I will get, here it is log of x. So this is in the form of infinity into 0. Yes, and infinity into 0 means it is in the form of 0 by 0, easily can be converted and we can solve it. Now the question is, all those examples are given. There are so many, 14 examples are given, and we can identify that a specific given function are in which format. These are all in different formats, and whatever those examples we have here, no one can be solved in our usual method because these all are the indeterminate forms. So now let me just give a brief summary that there are indeterminate forms means either the given function is in the 0 by 0 format, otherwise it is infinity by infinity format, or it is infinity minus infinity format, or 0 into infinity, or 0 to the power 0, or 1 to the power 0, or infinity to the power 0. Any of these form are in the indeterminate form, and if these are the formats, then these are the functions we can write here. Infinity by infinity, all are the in denominator numerator form. So two functions definitely included in the indeterminate form. One is fx, another one is gx. If it is infinity by infinity, then fx by gx is there, and definitely both for the limiting case tending to the limit infinity by infinity. Similarly, if this one is a function, so then fx and gx, and both are tending to infinity by infinity. And these are, we consider one as fx, one as gx. Here it is fx to the power gx. Here also all are same. So after getting this way, what we will do here, if this is in the infinity by infinity format, then always we can convert the function in this way to get our 0 by 0 format. Similarly, if it is infinity minus infinity, then we should convert the function into the 0 by 0 format by this transformation. For 0 into infinity, this is the transformation, and for all these three, the transformation, here it is for fx to the power gx, we take log on both sides, so that we will get this type of form, and which is definitely in the form of 0 into infinity. So once you will get the 0 into infinity, then from there, if we apply this transformation, then we shall find out it is into the 0 by 0 format. So ultimately, whatever the different forms are, all are converging towards the form of 0 by 0. So if we know how to find out the value for the indeterminate form 0 by 0, we can able to solve any other indeterminate forms. So if we want to solve these indeterminate forms, then here is the rule. So what is this rule? This is called the L'Hopital rule or L'Hopital theorem. What the theorem says? Here two functions are given. So let fx and gx are the two functions which are real valued functions in such a manner that the limit x tends to a, fx is equals to 0 or infinity, and gx also tending to the same value 0 or infinity. That means if fx is equals to 0, then gx is also 0, and if fx tends to infinity, then gx should tend to infinity. And the derivative of this function at this point, that is f dash a and similarly g dash a, both should exist where definitely g dash a not equals to 0. If it is so, then we can have that limit a tends to, that means limiting value for this fx by gx should be equal to the limiting value at this limiting point, that means f dash a divided by g dash a. That means it is very simple. Just fx by gx, whatever it is be given, if it is in the 0 by 0 format or it is in the infinity by infinity format, we just simply take the derivative of fx and derivative of gx. After that we should find out that this derivative of gx at this limiting point is 0 or not. If it is not equals to 0, then whatever be the derivative forms you shall find out, just substitute the limiting value, and whatever be the value you shall find out, that is your result. So let us do this one with the examples solved. That means so many examples we have in this lecture, and all those examples now we are going to solve. So at first it is the first example. Here we know that fx and gx, and then let me write it as limit x tends to 0, then it is x square divided by e to the power x minus 1. So that one is, we just take the derivative of the denominator and numerator. So just let me write down limit x tends to 0, then the derivative of x square means, I hope you know, that is 2x, and the derivative for e to the power x minus 1, if we consider, then it is only e to the power x because derivative of 1 is 0. Now we just check that when we substitute x is equals to 0, then this value is what? It is e to the power 0 means 1, which is not equals to 0. That means we should stop here and we just simply substitute the value of this x. So if we substitute, then we shall find it out as it is 2 into 0 divided by e to the power 0. That means it is 0 by 1, that is 0. So this is the value. Okay, so I think it is very simple. Let us do the next one. So for this next one, again we just write it down, limit x tends to 0, and then it is x e to the power x minus of log 1 plus x divided by x square. Very simple. We again take the limit on, that is we take the derivative on denominator and numerator, and if we take the derivative, then I hope its derivative is very simple, it is 2x, and if we take the derivative for this one, then it is the x e to the power x, means x is the first function, e to the power x is the second function, then plus derivative of the first means 1 and the derivative of second means this one, and log for, we know the derivative is 1 upon the given function, so it is 1 upon x. Now the derivative of x is 1, so it is all. So after getting this one, if we substitute the x is equals to 0, then x, this part is 0, e to the power 0 means 1, and here it is minus of 1, so it is 0 divided by 0. So this is, this derived form is again in the form of 0 by 0. So we will do the process again, that means we just repeat our process. So after that we again take the derivative of denominator and numerator both, so that now we will find out what it is. If we take the derivative of, for this one, then it is x e to the power x plus e to the power x. The derivative of e to the power x is e to the power x, and the derivative for this one means it is 1 plus x its whole square, and then it is minus of 1. I hope you know the derivative, and after that it is 2. So definitely it is not equals to 0, so we should stop our process here, and after that if we substitute the values, then we shall find out, here it is 0, then this part is 0, then e to the power, here it is 2 into e to the power x. So it is 2 e to the power 0 means 2 into e to the power 0, and here it is, if we substitute 0, then it is 1 divided by 1 plus 0 its whole square and divided by 2. So that means it is 2 and it is 1, so it is 2, then it is minus 1 divided by 2, so it is 1 upon 2. So this is our answer. Now the third question. So for the third question, what we will do here? So if similar process, we will take the limit x tends to 1 here. So it is the 1 plus log x minus x divided by 1 plus 2x minus of x square. Here it is plus and this is minus. Okay, so if we just simply take the derivative for denominator and numerator both, so that it is 1 by x minus of 1, and here we shall find out it is minus 2 plus of 2x. So now if we substitute x is equals to 1, then we shall find out it is 0 by 0. So this is again in the form of 0 by 0. That means we do that process again. That means we repeat our process again. So again if we do so, then we shall find out here it is minus of 1 upon x square, then divided by it is 0, so that it is only 2. Now if we substitute the value here, just look, this one is not equals to 0. That means we should stop our process here. Now if we substitute the value, then we shall find it out. Here it is minus of 1 upon 2. So this is our answer. So I told you that if the form is infinity by infinity, then we will do the same process. No change is required. That means that is not at all required to convert it into the 0 by 0 format. So that if we do so, then here we shall find out limit x tends to infinity. It is x square divided by e to the power x. We take the derivative for the denominator and numerator both, so that we shall find it out, this one. And now if we substitute, it is again in the form of infinity by infinity, yes. So that we do the process repetition. So it is given us, it is 2 divided by e to the power x. So now we shall find out it is 2 by e to the power of x. That means e to the power infinity by 2, which is not in the form of infinity by infinity anymore. So now we shall find out here that 2 by infinity, so anything divided by infinity is 0. So the limiting value is 0 here. Now the next question. In the next question here it is the limit x tends to pi by 2, and if we take it is the log of x minus pi by 2 divided by 10x. So definitely we take the derivative for the denominator and numerator, so that we shall find it out as 1 upon x minus pi by 2, and its derivative is 1, so let it be. And then 10x, its derivative is 6 square x, so that we can rewrite as limit x tends to pi by 2. 6 square means we know this is 1 by cos, so it is cos square x divided by x minus of pi by 2, which is in the form of, if we substitute, then we know cos square pi by 2 cos pi by 2 means it is 0, and here it is 0, so it is in the form of 0 by 0. So we will take again the derivative, so that it is limit x tends to pi by 2. If we take the derivative, then we shall find out the value as minus of 2 cos x sin x, and then divided by 1 only, which is no more in the 0 by 0 format. And now if we substitute these values, then we shall find out the value is 0. So this is the limiting value. Now one more example here. So if this one we are going to solve, then here it is the limit x tends to infinity. Definitely we substitute this one instead of this fx. So it is 2x cube plus of 3x square plus of 6 plus of x divided by, here it is 6 into x cube. Now if we take the derivative, then it is, we shall find out limit x tends to infinity, and it is 6 of x square plus of 6x plus of 1 divided by 6 into 3 means 18 of x square, which is again in the form of infinity by infinity. So we take the derivative again. So if we take the derivative again, then it is 12x plus of 6 divided by 36 of x, which is again in the form of infinity by infinity. So one more time we should take the same process. So finally now we shall find it out. It is 12 by 36, which is nothing but is equals to 1 by 3. So which is our value for this limit. So now if our form is infinity minus infinity, then we should rewrite the given term in this format that we continue, and after that it is in the form of 0 by 0. That's why what we will do here, we just find it out that limit x tends to 0. Here if we simplify this, then we take the derivative in the denominator and numerator, so that it is cos of x minus first function derivative of second function, but cos x, its derivative means minus will be there, so then it is cos of x, and then divided by first function derivative of second, then minus plus of the sin x. This is the derivative, and these two cancel out. So after that we shall find out this format, which is again 0 by 0 format. So it is in the form of 0 by 0. So we will do the things same, and we just repeat the process once more. So this is limit x tends to 0, and if we take the limit, so that is the derivative, so that we shall find out x cos x, because x sin x is there, first function derivative of second, plus of second function derivative of first. After that here also the first function derivative of second, then plus of derivative of the second function, it is the cos x, so its derivative is 1, then plus of it is the cos x. This one is 0, but here we shall find out 2, because cos 0 is 1, cos 0 1, so 2. So finally we shall find out 0 by 2, that means 0 is the limiting value. Now one more question is here. In this question, if we want to solve, then again this is in the form of infinity minus infinity. We should convert it into the form of either infinity by infinity or 0 by 0. So if we want to do so, then it is limit x tends to 1, and we just simply take the LCM. So if we take the LCM, then we shall find out it is log of x, and it is x log x minus of x, then plus of 1. So now if we just substitute the value x is equals to 1, then we shall find out it is 0, and this is 0, this is 0, so it is in the form of 0 by 0. So after that we take the derivative on the denominator and numerator, and we shall find out x into 1 by x minus of log x, it is plus of log x, then minus of 1, then divided by x minus 1 into 1 upon x, then plus of log of x. So this is 1 and this is minus 1, so this portion will be cancelled out. So log x, log 1, I know, that means we know that it is log 1 is always 0, and here it is, if we just separate x by x, that means 1 minus 1 upon x, so for that it is 0 and log 1 0, so it is again in the form of 0 by 0. So if we simplify, then we shall find it out as, here it is 1 upon x, and here for it is 1, so it is minus of 1 upon x square, then plus of 1 by x. So from here we just simplify, and we just do one thing. Here we take 1 upon x common, and if we cancel it out, then it is minus of 1 by x plus 1. Now it is not in the form of 0 by 0, and if we substitute x is equals to 1, then is x is equals to, sorry, here it is 1. So then we shall find it out that it is 1 by 1, so it is 0. Sorry, this becomes plus, because here already minus is given and 1 upon x is there, and if we take its derivative, then it is plus of 1 upon x square, so it is plus. So we shall find it out, it is equals to 1 upon 2, which is the limiting value. So in this way we can easily calculate the indeterminate forms. So now come to this function, and here we shall find out that it is limit x tends to 0, and we just rewrite in the form of 0 by 0. So that we just write it down as log of x, suppose it is divided by 1 upon sin x, which can be again written as log of x divided by 1 upon sin x, means we know that it is the cosec x. Now log 0 is infinity, so this is in the form of infinity by infinity. So as it is infinity by infinity, the same process we follow, and we just simply take the derivative of the denominator and numerator, and here by taking the derivative we just find out the cosec x, cot x. So if we simplify, then it becomes cosec means 1 by sine, cot means cos by sine, so that we shall find it out from here. It is the sine square x divided by x into cos x. Here minus sign is there, so limit x tends to infinity is also given. Okay, so again now if we substitute the value, then it is the it is 0. The limiting value is given as 0, not infinity. So sine 0 0, cos 0 1, but here it is 0. So this is again in the form of 0 by 0. So as it is in the form of 0 by 0, show that we just simply again take the derivative. We take minus outside, so that limit x tends to 0. Now its derivative is 2 sin x cos x, and its derivative is first function derivative is cos x, its derivative is sin x, so it is minus then plus of cos x finally. So now from here we just substitute the limiting value, so that we shall find it out that this one is 0 and it is 0 and cos 0 is 1. So it is no more in the 0 by 0 form, so that it is minus of 0 by 1, so that it is finally 0, so that the limiting value is 0. Now let us go for the another question. So the another question is this one. Here again for the given function is limit x tends to pi by 2, and it is in the 0 cross infinity, that means 0 into infinity indeterminate form, and that we should again rewrite in the form of here it is 1 minus of sin x divided by tan x, means we can write it as cot x. So now if we substitute the pi by 2 value, then we shall find out it is 0 by 0 form. So it is the form 0 by 0. So in this form 0 by 0, if we just simplify, then we can find it out as we take the derivative, and it is the minus of cos x, and cot x means it is minus of cos x square x. So now if we just simplify again, that means we just simply substitute the value pi by 2. Then if we substitute, so then we find out that this cos pi by 2 is 1, cos pi by 2 is 0, whereas cos x square pi by 2 is 1. So if we just substitute, we shall find out it is the limiting value is 0. Now it is the different type of questions. So I tell you that if the indeterminate forms are of the form 0 to the power 0 or infinity to the power 0 or 1 to the power infinity, then we just take the log on both sides. So accordingly here we take the log on both sides, so that it is becoming in the form of this form. So if this form we find out, then to solve this one we just take like this one, limit here, the limit will not change. Here the limiting value is we should write y tends to 0. It is, we rewrite in the form x tends to 0, it is log of y, then is equals to, this one is limit x tends to 0, and that form we should write it as log of x plus of sin x divided by 1 upon tan x, that means it is cot x, we should write it down, and it is in the form of infinity by infinity. So now we take the derivative for the denominator and numerator. We shall find it out as, here for we find out as 1 upon x plus sin x, and its derivative means it is 1 plus cos x. Then it is, and for this one it is 1 upon minus of cos x square x. So if we simplify this one, then we shall find it out as limit x tends to 0. Then for simplification, from here we just write it is sin square x, then it is 1 plus cos x and divided by x plus sin x, and this negative sign we just write it down on the outside. And this is, if we substitute x tends to 0, we shall find out it is the form 0 by 0. Okay. So now if we again take the derivative and after that we substitute, then suppose we take the derivative, here minus sign is in the outside, and after taking the derivative here we shall find out as sine cube of x plus 2 into 1 plus cos x, then sin x and cos x. Okay, and then divided by, here from it is 1 plus cos x, and if we substitute the x limit, then we find it out. Here it is 0 minus of 0 by 2, so that is nothing but 0. So this is our limiting value. Now the one more question, here it is in the form of 0 to the power infinity. Here the same way we take the log value in this way, and after that when we are going to take the limiting value, that means here it is the limit x tends to 0 of y, then it is okay. One more thing, just let me tell you that in the previous question this is the value of log y. If we want to value of y only, then it has to be e to the power 0, so that is 1. So the limiting value for this given one, this one is, it is 1, not 0. Okay, 0 for the log of y. Now similarly, because I told you that we should take the log and after that we take the anti-log also. So now for this one, if we just substitute, then here it is the limit x tends to 0, and then it is, we just rewrite as we have taken the log on both sides, so here it is the log should be substituted, so it is the log of e to the power x plus x divided by 1 of 1 by 1 upon x, means it is finally getting as x. And now it is in the form of, here the limit is given infinity, so in form of infinity by infinity. So for this format, what we will do, we take the derivative for the denominator and numerator, and if we shall take the derivative, then it is e to the power x plus x, and it is e to the power x plus 1, and then divided by it is 1. So this is, we shall find it out. So that means here now this is the if we just rewrite it as this one, so e to the power x plus 1 divided by e to the power x plus x. So for this one, it is again in the form of here it is infinity by infinity, because here the e to the power infinity means infinity, and this one giving us the infinity. So again we take the derivative and we find out e to the power x divided by e to the power x plus 1. Now if we just substitute the value of the limit, that means e to the power x means it is e to the power infinity, so it is infinity, so again in the form of infinity by infinity. And if we simplify, then we shall find it out it as e to the power x by e to the power x, that means it is, finally we find out as 1. So this is the value for the log of y, and for the value it is y is equals to e to the power 1, means it is the e, because we have to take the anti-log, so this is our result. Here is one more question, and here also the same way we proceed. Here again log we have to take, and after that we just reconstruct in the form of 0 by 0 or infinity by infinity and solve just like the previous two. And this one is the final one. One more question, just we rewrite it in the form of 0 by 0 or infinity by infinity, and we should solve it out. So hope you can understand what the indeterminate form is and what is the L'Hopital rule, and based on that how to identify a given function, a given limiting function, that it is indeterminate or not, and if it is an indeterminate form, then which form is it is. After identifying the form, we should transform into the 0 by 0 form or infinity by infinity form, and after that we should solve it. Now here something for you, it is the do by yourself question, and I hope you can observe these questions. These all are the very well-known limiting values to you. These all are the standard limit. These are the limit formulas. So how to get the value for those limiting formulas, that you should find it out, because all those functions are the indeterminate form, and I hope now you can able to do this. Just solve it out and write me in the comment box that how you like this lecture. And in the next lecture, I will explain that how this L'Hopital rule will come. That means the explanation of the L'Hopital rule. So thank you all till that. Have a nice day.